Alright, so today we're talking about definitions of points, lines, and planes. So to do that, let's go through a bunch of definitions. So a point is simply a location. It is a place that we find things. So it is a location. They have no size or shape. Okay. And they're always represented like this with a dot with a letter next to it. We have these things when we do geometry that do shorthand notation. So it's like shortcuts when we're trying to explain something to somebody else. And for points, we use a capital letter to name a point. So in this case, if I was to name point A writing-wise, I would just write capital A. A line is made up of many points. Okay, it's just a bunch of points that form a line. Okay, it takes exactly 2 points to form a line. It has no thickness or width. Okay. Remember, we can name a line by any 2 points that are on the line. So in this case, I would put a capital X and Y. And with lines, you have to put a symbol above them. So in this case, I have to put a line with two arrows around it because those looking at this picture, this line goes in both directions. They are bidirectional, which means I could also say line YX. Okay. Or it says I can use the lowercase script letter that is next. Now everybody see this lowercase script letter here. Okay, so I could literally say line and collinear points are points that lie on the same line. So any point that falls on the same line is considered collinear. Okay, non-collinear points are points that do not lie on the same line. But note here, down here in the bottom, that they must be at least 3 points on the graph. Meaning I would have to have another point like out here, and now X, Y, and Z are non-collinear. Okay. One definition that I forgot to put on here is called a ray. Okay, a ray is a line that goes indefinitely in one direction. Okay, so I have ray AB. Okay, so notice it goes in one direction. So when I name this, I write the two letters A to B, and the arrow must go in the direction that you have. Okay, so you always put the endpoint on the end. Okay, a plane is a flat surface. Okay, it's made up of 3 points. The plane extends indefinitely in all directions. Okay, we can name a plane by 3 non-collinear points. So that's the key here. They have to be non-collinear. Okay, non-collinear. Okay, or an uppercase script that's in the corner. So I could say in this case I have plane and the 3 letters KJL. Does not matter what order you put those letters in. Okay. Or if you see down here this little letter that has no dot next to it, that means that's a script letter. So I can also say plane P. Okay. Coplanar points are points that lie on the same plane. Non-coplanar points are points that do not lie on the same plane, but then again, just like in the non-collinear line part, okay, they must be at least 4 points. So meaning I would have to have another point somewhere out here, like say this one. I could say I have a point out here that is X. Now K, J, L, and X are non-coplanar. They don't lie on the same plane. Okay, we also have two lines that intersect to form a point. Okay, that is always the cool rule. If you have two lines that intersect, they always intersect at a point. If you have two planes that intersect, they always intersect at a line. Okay, I'm going to do some examples, walk you through a couple things, and then we'll be on our way and with this set of notes. So we have four coplanar points, or collinear points. So we need to find 4 points that lie on the same line. If you look at this line, that only has 3 points on it, so it can't be that one. If you look at this one, that only has 3 on it, so it can't be that one. But if I go this way, there it is. There's my 4 collinear line points. It's H, N, K, and I. A line that contains point M is right here. So I could say line MO. Remember, put the arrows above your to know that it is a line. A line that contains 8 points H and K is this one. So I could say line R by that little subscript out here. Okay, I also could have said NI, many different ways for it. Okay, line Q is this bottom line down here. Okay, so I could say line JL, put that arrow above it, and there now you have a line. Okay, and the intersection, let me erase all this. The intersection of line P, so line P is this one here, by that subscript right there, and R, which is this one, I know that by that script down there. And you know, 2 lines we said always meet at a point. That point they meet at is right there, which is N. Okay. We need a line that contains point F, so find F, which is right there. So a line that would contain that would be line DF. Okay. Another name for line K. K is the one that goes up and it goes through the plane there. So I could say line BC. Okay. We need a plane that contains point A. Okay. Remember, it takes 3. Remember, when you're naming a plane, you always say plane, and then it takes 3 non-collinear points. So it would be plane A, E, F. Okay, 3 non-collinear points could be any points that don't fall in the same line. So like B, D, and A. Okay, and the intersection of this plane, okay, this outside thing, and the line that comes through the middle is this point right here of E. All right, so we need 3 coplanar points, so 3 points that lie on the same plane. You can pull any of them. Okay, there's many different points here. I could tool these 3 right here, which would be V, Y, and Z. Okay, so that could be one of them. I could also said anything else basically. Okay, and then point X. Point X is right here. I need a plane that contains it, so I could say Z, W, X. Okay, oh, don't forget the word plane, like I just did. So plane WZX, okay, because it takes 3 points to name a plane. The intersection of plane R is this plane that is on the bottom, okay, and plane ZVT, well, if I look for ZVT, ZV, or CVY, sorry, CVY is this side. Okay, and the intersection of 2 points is always a line, so it would be line VY. But I'm not going to put arrows on it because they don't go on forever. They have 2 endpoints. Okay, there are technically 5 planes. The ones I just marked. This one in the front. This one on this side. And you also have one in the back. So there's 4 on the triangle and then the one big one on the bottom. So there are technically 5. And how many of them contain W? Well, W is right here, so that's connected to 1 here, 2 here, and 3 on the bottom. Okay, last one. What is the intersection of line L and line M? Well, line L is the one that goes this way. Line M is the one that goes this way, so they meet at that point right there, which would be E. Next one says, name another plane for plane Q. So I need 3 points. So I'm going to say plane. Remember, the points have to be non-collinear. So plane E, G, and I. Okay. Are points D and points E collinear or coplanar? Well, they're definitely not on the same plane because E is in Q and D is in P, but they are on the same line here, so they would be collinear. Okay, and how many times do planes P and Q intersect? Okay, the two planes actually don't cross each other, so 0.